Okay, so I did the problem from the homework. I wrote down my basic information to start off with, unit cost, unit price, all that good stuff. I made my table with states of nature at top and decision alternatives on the side. And I filled in all my states of nature and my decision alternatives, which I get from the table that he gave us in the homework. The demand in crates would be your state of nature, and also it would be your decision alternatives. And the probabilities at the bottom come from, if you add up the number of days, it'll give you 292. And if you take each individual number and divide it by 292, like 55 divided by 292, then you'll get all your probabilities for each state of nature that they go with. Okay, and then I portion my table into different areas because the areas are going to follow certain patterns so that you don't have to calculate each and every one of the payoffs, because that would be tedious. You start with area 1, which is the diagonal little line across where demand will equal how much you bought. So your state of nature and decision alternatives will be equal, which would be D1S1, D2S2, and so forth. So if you start with that, to get your payoff for D1S1, you would take 37 and multiply it by 819, because you have to pay 819 for each crate. And your decision alternative for your first state of nature is 37. So you bought 37 crates, and it cost you $303.03. So that's a negative cost. And you sold 37 crates at $10.67, which gave you $394.79. So your whole net profit is $91.76. So doing D2S2 means you would buy 38 crates and you would sell 38 crates too. So 38 crates at the price it costs you would be $311.22, which is a negative cost. And if you sell 38, then you'll make $405.46. But if you subtract your negative cost from that, it would be $94.24. So if you look at the pattern that they follow, your net profit for each unit is $248. So if you were to sell one more unit, then you would get an additional $248. So, and that's the pattern that area 1 follows. So like at D3S3, you're selling 39. You bought 39 and you're selling 39. So that would give you an additional $2.48. And so on forth through the diagonal line. If you just add 248, you don't have to calculate them all. Okay, so area 2, it leaves off, it starts from area 1 and it goes on each row to the right. If you look at D1S2, it would be that you bought 37 crates at $8.19. And even though your demand, even though there's 38 people that want them, you can only sell 37 because that's all you have. There's nothing you can do about that customer that wanted one that didn't get one. So your net profit is going to be the same as the D1S1, the same as before, because it doesn't matter really how many people want them. Your demand, according to the states of nature, could be 1 million, but if you only have 37 crates, that's all you can sell. So your profit would be $91.76 across the first row. Same with D2, S2. If you buy 38 crates and sell 38, then you'd make a net profit of $94.24. If you look at D2, S3, you still bought 38 and you can still only sell 38. So once again, the demand doesn't matter. It's the number stays the same across the row from area 1. Area 3. Area 3 is where you have a surplus. You bought too many, people didn't want them, so you're going to have to sell them at a lower price in order to get rid of them, which will mean you have to eat some of the cost. So if you do a calculation, let's see, of D2 S1, it would mean that you bought 38 crates at $8.19, but you could only sell 37 of them. So that would give you $394.79. The extra left over you would sell the next day for $1.99. So you'd add that to it, your net profit, which would give you $85.56. If you calculate D3 S1, it would mean that you bought 39 crates at $8.19, but you could only sell 37. So you'd have 2 left over the next day that you would sell at $1.99, which would give you a net profit of $79.36. So these follow a pattern of your unit cost minus the sale price. You paid $8.19 per crate, but if you had to sell them at $1.99, that's all the money that you could get back. So you have to eat really $6.20. So starting from area 1 on each of the columns going down, if you subtract $6.20, then you'll get your payoff. And once you figure out the patterns, then you don't have to, or once you know the patterns, or even just the very bare information he gives you in the beginning, you can figure it out. You probably don't really have to even calculate but one number, but I'd do it just to, be on the safe side. So, yeah, and there's the homework.